Hello and welcome. In this lecture we are going to do a lot of topics. We are going to look at operators. There are different kinds of operators: arithmetic, assignment, relational, logical. Then we are going to look at the priority of operators, then expressions, associativity, type conversions, conversions between data types, and storage classes, where are variables stored in computer memory. Okay, let us start by learning what are operators in C. What are the different types of operators supported by the C language. But first of all, we need to know what an operator is. For that, let me write an example here. We had an expression: area is equal to length into breadth, L into B. So we can easily infer from this expression that these two symbols we have here are nothing but operators, right? Equal to is an operator. It operates upon two operands. Multiplication is an operator. It multiplies length with breadth, right? Let us take another example where we have this expression: simple interest is equal to PNR upon 100. So P into N into R in parenthesis upon 100. So what do we have as operators in this expression? So we have first of all the equal to sign as operator, then comes multiplication signs, and then this division sign as operator. So it's clear that an operator is nothing but a symbol, right? And after that, what you see in these expressions are these, what are underlined in orange, are nothing but operands, right? These are variables or some constant values. So an operator does nothing but it operates upon operands. So it operates, does some action, right? Operates on operands. So there are several operators supported by the C language. Let me write all of them for you here. So these are the operators, different types of operators supported by the C language. We have arithmetic operators, which operate upon arithmetic constants or arithmetic variables. We have relational operators. We have logical operators, which deal with logics, truth and falsity. We have the assignment operator. This is an assignment operator, the equal to sign. We have increment and decrement operators, which add 1 to a value, or decrement which minuses 1 from a value. We have conditional operators, which deal with conditions. We have bitwise operators, which deal with bits, and there are some special cases too. Okay, now let us talk about arithmetic operators. Let me list all of the arithmetic operators that are supported by the C language. We have plus, we have minus, we have multiplication, division, and a special kind of operator known as modular division, which is very popular in computer science. So multiplication, plus, minus, division, and modular division. Everybody knows how these works. Let us take a few examples to recap. So let us take integers. So 5 plus 2, if we take the example of plus, so 5 plus 2 will always give you 7, right? In C also, 5 minus 2 will give you 3. If you multiply 5 into 2, remember that this is for the integer data type. If you take integers and apply these arithmetic operators to them, we get these following results in C language. 5 into 2 is 10, as desired by us. 5 divided by 2 will be not 2.5, it will be 2, because an integer operation will always yield an integer. So we can write here that whenever a decimal is divided with a decimal, and if the output is in points, so if that is the case, then the decimal part is truncated. Decimal part truncated. Please remember this, because it's very important. People make mistakes, a lot of mistakes in these things. So to recap again, if we divide two integers and the result in our mind is a floating point number, so in that case the floating point is dropped. The part after the decimal point is dropped. Now let us look at this sweet modular division operator. So 5 mod 2 will give you 1. Let me show you how. 1 is actually a remainder of the division of 5 by 2. Then let us look at this how. So 5 2 2 2s are 4, 2 2s are 4, and we get 1, and this is the remainder. And this is what we get if we mod 5 with 2. Okay, now let us try these things with the floating point numbers. So with reals, if we have 5.0 plus 2.0, so let me write all of these operations first, and then we'll look at the results thereafter. So coming back to the results of all of these operations, so 5.0 plus 2.0 will give you the same 7.0, but real is actually followed by, after the decimal number, after the decimal point, we have 6 digits. So instead of 1 0 we have 6 zeros. Same is the case with 5.0 minus 2.0, we have 3.6 zeros. 5.0 into 2.0, 10, right? But always be a floating point number, so 6 zeros again. And 5.0 by 2.0, and this time we'll get the correct value, because a float operated upon a float will always give a float. So this time we'll get 2.5, and then after the decimal point we have 6 digits. So one is 5, and others will be replaced by zeros. So these are all padded with zeros. And the most important thing is that the modular division operation cannot be performed. It cannot be performed on floating point numbers. Okay, I want you to remember a few things now. Let me write a table, because there is a lot of confusion. What operation will yield what result? We know the result in natural mathematics, but in computer science, or in the C language to be particular, there is a little bit of difference. So if you operate an int with an integer, if an int is operated upon an integer, you will always get an integer. If the case is with float and floats, when you operate upon two floats, the result is always a float. If you take another case where one of the operands is integer and another is float, what you get is a float. If both are floats, which we saw in previous examples, float and float, you always get a float. So if you look at this table, if you look at this table carefully, you'll notice that if any one if any one of the operations is, if any one in the expression, if any one of the operands in the expression is a float, you get float. For integer, you have to be the expression must contain both of the operands as integers, so that will yield an integer, otherwise it will yield a float. That is to be confirmed. Okay, now let us quickly review what an assignment operator is. So we have used an assignment operator a couple of times. What an assignment operator does is nothing but it assigns a value to a variable. So you have a variable like a radius of a circle, and you say that radius is equal to 5. So this is an assignment operator. This equal to is an assignment operator. What it does is nothing but what you have on the right hand side, it assigns that value to the left hand side. So it does nothing but it assigns the value of right hand side to the left hand side. So LHS is given the value of RHS. Now there are certain rules that you have to follow. When you say, if you say A is equal to 5, it is correct, because you can have a variable on the left hand side and a constant on the right hand side. So constant gets assigned to the variable. If you have A equals to B, then it is also correct, because value of one variable can be assigned to a value of another variable. If you say 5 is equal to A, then this gets wrong, because you cannot assign a value to a constant. A constant already has its own value, right? And if you have an expression on the right hand side, B plus C, whatever it is, so then it is also correct. You cannot have an expression on the left hand side. This is wrong, because an expression yields some constant value and you cannot assign some other value to a constant, right? So this is how an assignment operator works, and you have to know these rules of using an assignment operator, else it will cause errors. Now coming to logical operators, they are same as the maths operator which we have, the operators which we have in math. They are the same in C here. The primary operators, let me write a table here. We have operator in what we have in math and what we have in C. Okay, so we have three operators, right? And, or, and not. In mathematics, and is denoted by this sign, or is denoted by this sign, and not is denoted by a tilde, right? C has some other ways of denoting operators, right? And is denoted in C by a double ampersand, or by double pipes, and a not by an exclamation mark. So it's the same as in math, just the symbol is quite different. So you must know this is an ampersand. This, a single line, vertical line, is a pipe, and an exclamation is, you know, an exclamation, right? So what do we have as result of any logical operation? So the result is nothing but result is either true or false. Any logical operation yields true or false and nothing else. Now let's draw truth tables for logical operators. Let me write all the truth tables for all the operators, then we'll discuss it quickly. Okay, we have the tables ready here. Now let's go through them quickly. Now in A we have true and B we have true value. So what would be the AND of true and true? Will be always true. If we have true and false, we have false. If false and true gives false, false and false give false. Similarly, true or true will give true, true or false will give true, false or true will give true, and false or false will false. A simplest way to remember this is like AND is a multiplication and OR is addition. Consider true as 1, false as 0. So 1 into 1 is 1, that is true. 1 into 0 is 0, right? 0 into 1 is 0. 0 into 0 is 0. If we have plus, 1 plus 1 is 2, that is a positive number, so it is true. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0, that is false. So this way you can remember the truth table, and it's so easy, and I guess everybody knows the truth table for AND, OR and NOT at least, right? NOT is very simple. The opposite. If it's true, not of true is false. Not of false is true. It's so simple. Now let us look at relational operators offered by the C language. Relational operators, as the name suggests, is a mathematical concept. Now in mathematics we have relations. We have something greater than something, something less than something, something equal to something. So the same concept applies in C. So first let us look at the operators in mathematics, then we'll relate them to C language. We have less than operator, we have greater than operator, we have less than equal to, then greater than equal to, and we have equals to for equality, relational equality, and we have not equal to, the relational inequality. Remember 8th standard inequalities, relations, the chapters. Remember those chapters. Now in C, less than is represented as less than, because the less than key is available on your keyboard, right? Greater than is the right angle bracket. Less than equals to, the symbol is not available on your keyboard, so there's a workaround. Less than equal to is represented like this: less than and equal to, 2 characters. Greater than equal to, you guessed it right, greater than equals to. It's so simple. Now equal to can be represented as equal to, but the designers of C were very clever. Now you already have an assignment operator as equal to. Now you cannot use the same equal to here, so as a workaround what they did was double equals to. So for equality, for relational equality, you have double equal to, and for not equal to we have not and equals to. It's so simple. Now one thing one must remember, that relational equality is not represented by a single equal to. Single equal to is assignment, and double equal to is relational equality, right? Now let us look at some examples and get some results out of them. So if we take 5 less than 8, now one thing one must remember, that relational operators also give one result, either true or false. So is 5, ask yourself a question, is 5 less than 8? Yes, it is, so true. If you take 3 is greater than equal to 3, now is 3 greater than or equal to 3? Yes, 3 is equal to 3, right? So true. 5 is equals to 5. This is also true. Yes, 5 is equal to 5. If we take 2 greater than 10, this is false. Is 3 not equals to 6? This is true. So this way any relational expression can be solved. Okay, with that said, let us look at a very simple and subtle topic. Let's say we have this expression a plus b. Now this plus has two operands, right? These are operands, a and b are operands. So this plus has two operands, right? If we take not a, so a is a single operand of this operator. So not operator has one operand, plus has two operands. So there comes a little fact here. Let us make a table here. Number of operands. Now if the number of operand is 1, then the operator is called a unary operator. If the number of operands are 2, then that operator is called a binary operator. And if the number of operands are 3, then that operator is called a ternary operator. Now you can easily, from what we have studied so far, you can easily infer that plus is a binary operator because it has got two operands. It always operates upon two operands. The not operator is a unary operator because it operates on only one operand. Okay, now let's delve into this topic. Have you heard about the BODMAS rule in mathematics, wherein the operators have a priority? We solve first division. First we solve bracket, then division, then multiplication, and then so on. So the operators have a hierarchy, right? Now C has a similar concept, but quite different from mathematics. In C, there is a priority or precedence or hierarchy given to operators. Now let me write the hierarchy of operators. In C, you have to solve that operator first. So the first operator in any expression, if it contains that operator, you have to solve that first. So the highest priority is given to the not operator. After that, in the second level of hierarchy, we have multiplication, division, or modulo division. In the third level, you have to solve plus or minus, addition or subtraction. In the fourth level of hierarchy, you have relational operators: less than, greater than, less than equals to, greater than equals to. After that, you have relational equality, double equals to, and relational inequality. Then you have the AND operator, after that the OR operator, and then the least priority to be given is to the assignment operator. Now this is the priority which C follows. So this is increasing level of hierarchy, right? So just to remember, whenever you solve any expression or whenever you write a program which deals with expressions, so this priority needs to be maintained, needs to be taken into consideration. But the first and the foremost thing in an expression to be solved is bracket. So bracket enjoy the topmost priority. First you solve bracket, then other. Let us turn our attention to expressions now. Expressions are of different types. If that expression contains logical operators, then it's a logical expression. If it contains arithmetic operators, it's an arithmetic expression. Same as with relational, and there are a lot of various types of expressions. Now if you don't know, an expression is nothing but something which contains operators and operands, right? Now, taking the example of arithmetic expressions, which are expressions which involve arithmetic operators. Now, arithmetic means mathematical in the sense. Now, maths has its own way of handling operators, and it defines its own symbols. Now, C cannot use mathematical symbols because there are some limitations, like division cannot be represented in plain text, right? So C has some workarounds. Now, so you have to convert mathematical expressions into C expressions. Let us take a few examples here. So we have algebraic expressions and their C expression equivalents. So A into B minus C, so the into sign is represented by asterisk in C. If we have P plus Q multiplied by P minus Q, so in maths you assume that here it is multiplication, even if you don't write it, but you have to tell explicitly in the C language if there's multiplication or not. If you drop this sign, it will show an error. AB by C is represented by A into B divided by C, right? 9x square, so there is nothing like square in C language. You cannot have exponential terms, so you have to manually write them. So x square is 2 times x, so 9 asterisk x into x. So this is the way it is. Okay, now let us look at a simple term called as associativity. Associativity comes to the rescue when you have confusion upon which operator to operate upon first. Consider this expression x equals to 2 into 6 by 3. Now there is a confusion between which to solve first, multiplication or division, because in the C priority level, multiplication and division are on the same level of hierarchy. So which to solve first? Here comes associativity to your rescue. Associativity is nothing but a way to solve an expression. Now, associativity is something related to operators only. Now, when you take multiplication or division operators, you solve them left to right. You take the left operand and then the right operand. On contrary, if you take the assignment operator, you first take the right operand and then put it into the left operand. So this is associativity, the way of solving an operator, using an operator. Now the associativity of multiplication and division is left to right. Now you must be wondering how associativity will help us. Now let us take each operator and list its left operand and right operand. So if we take multiplication, left is 2 and the right operand is 6 by 3. If we take the division operator, the left is 2 into 6 and right is 3, right? Now if you look at it carefully, which is the most non-confusing operand, which does not have confusion? The left operand of the multiplication is not confusing because it's a constant. It is not, no operation needs to be done, right? And for division operator, we have the right operand as not confusing. Now what is the associativity of these multiplication or division? Multiplication is left to right, division is left to right. So the one whose left operand is not confusing because its associativity is left to right, whose left operand is not confusing will be solved first. So naturally multiplication will be solved first, right? Because its left operand is not confusing, non-confusing operand. Then only one operator remains, so x equals to 4. Let us take another example here. If a is equal to b is equal to 51. Now here is also a confusion of which to solve first. because equal to and equal to, obviously same priority, right? Now considering this first equal to, left is A, right is B equals to 51. Unambiguous means not confusing is left. If this equal to is taken into consideration, the left is A equals to B, right is 51. Now equals to is the associativity of equal to is right to left. So which equal to would be solved is whose right operand is unambiguous. So this equal to will be solved first, then this equal to. Now let us solve this expression var equals to 10 minus 12 divided by 3 plus 3 into 2 minus 1. So the first and the foremost thing is to solve the parenthesis, solve the brackets first. So the innermost brackets will be solved first, right? You do the same thing in mathematics, right? So 3 plus 3 would be solved first. What remains is the second inside bracket, but the insides of the second bracket contain some ambiguous operators, right? So here division and multiplication, so the left would be solved first. We learned this earlier in associativity, right? Left operator first, then the parenthesis, again the left operator first, right? Because minus and minus enjoy the same priority, so the left operator first, because the associativity of minus is left to right. And done. Var equals to 5. Now 5 will be assigned to var. Okay, now look at a little concept of type conversions. Type conversion is nothing but the conversion of one data type to another. If we have two incompatible data types, we have to convert one of them, right, for operation between them. Now we have learned this earlier in this lecture also. Int gives an integer, float gives float, int float gives float. Now any one of the operands is a float, that gives float. So if operation is 3 by 2, result is 1. Why? Because it involves two integers, right? If it's 2 by 3, the result is 0. Because it involves two integers, it gives the result as integer, and the decimal part is truncated, the floating point part is truncated, right? If any one of them is float, the result is float. That's all we have in this slide. Now that was type converting automatically. The compiler automatically type converts that. But there arise some situations where you have to manually type convert it, right? So if you take this example, you first declare a floating point variable var, then you assign var the value of 7 by 2. Now a normal person would go on by saying that var will contain 3.5, but let's look if it contains 3.5 or not. This is an operation between integer and integer, so the result will be an integer. 7 by 2 is 3.5, the decimal part is truncated, so we get 3. Output is 3.00. Where is the 5? So in such cases, this is wrong, right? In such cases, what we'll do is type convert manually. So float var and var is 7 by, now we will convert 2, which is an integer, to float by preceding it with a float. This is the way to type convert. We are converting one of the operands to a floating point number. So this time we'll get a perfectly correct value, absolutely correct value, 3.5, which is correct. Now this can be, there are approaches how you can convert one of the values to floating. You can write 7.0 by 2.0 or 7 by 2.0 or float in brackets 7 by 2, and there are several other ways. Now a final concept remains, which is of storage classes, which is very easy concept. But before you know what are storage classes, you must know this. Where do computers store data? There are two types of places where computers can store data. One is memory, another is CPU registers. Memory is nothing but RAM, and CPU registers are nothing but a type of memory which is inside CPU. Now RAM is slow memory because it is contained in a different chip. CPU is in another chip and RAM is in another chip, so it takes time for the signals to flow between them. Now CPU registers are directly contained inside the CPU, so they are the fastest memory available. Now RAM contains a lot of memory. It is unimaginably vast for your program, right? And CPU registers are limited in number. Now here comes storage class. This is important for you to know, right? And storage class. Now storage class, there are four types of storage classes: automatic, register, static, and external. Now why do we need storage classes? They tell us about the storage, right? We looked at the storage in earlier slide, memory or register, where to store the data of that variable. They tell us about the initial values. When you declare a variable, what value it will contain. They tell us, storage classes tells us the initial values, the life and scope. Now initial value is nothing but the value which is first contained in a variable when it is declared. Now, when a variable is declared, it may contain garbage value or it may be 0, right? And we talked about life and scope. Scope means you declare some variable in one part of our program, and if you want to access it from some other part of our program, then you cannot access it because it is limited. Its scope is limited. Now scope is nothing but a term which tells us that in which part the data cannot be accessed, in which part of the program the data cannot be accessed. Now let us look at automatic storage class. Now take this program, void main. You declare an auto int, automatic integer variable, a and b. You declare two variables and you print the value of these two variables. So first time you run the program, you might get this value 25 and 8. The second time you run this program, you might get another value. The third time you might get another value. So these values are not fixed. These are called garbage values. Now the initialization is garbage value for an automatic integer variable. Now let us look at the scope of variable. Now B scope, let us say we have, this is a program segment. Now in braces define the scope. In the outer braces we have declared an integer a, and a equals to 10. We have assigned a value 10 to a, and thereafter we create a pair of braces again, and inside that we declare another variable b and assign the value 15 to a inside. So B scope is defined by these braces because B is declared inside these two braces, and A scope is defined by these two braces because A is declared in these two braces. Now this operation A equals to 10 is successful because this statement is within A scope, right? And it is within A's block. If you consider this statement, A is equal to 15, this is also successful because this statement is also within A's block. Why? Because this is inside A's block. It is also inside B's block, but yes, it is inside A's block, so it is eligible for this statement, right? Now if you assign a value 4 to B or any other value to B outside B's block, outside B's scope, so it is not possible because it is not in B's block. So what I wanted to tell you is nothing but that scope is important in programming, right? Now if you say normally int, we have declared variables in our programs which we wrote previously, we just declared them as int. Now int is nothing but an auto int. You don't have to explicitly write auto. If you write, it's okay, the program runs. That is, auto is the default storage class, right? Now auto variable, auto integer, auto float, auto character, or any other automatic variable is stored in stack memory, is in a part of memory which is called a stack memory, which is inside RAM, not inside CPU registers. Its uninitialized value is garbage, right? When you declare it, it is undetermined. The value cannot be determined. It can be anything. The scope we looked at is defined by the block in which it is declared, right, within the braces. The lifetime is inside block. Once the control goes outside the block, you cannot access, you cannot use the variable, right? The variable dies after the control goes out of the block. Life and scope are very closely related terms. Auto is the default storage class, we know this. Now there comes register storage class, which is similar to auto storage class. The only difference is that register storage class, the variable is assigned the memory, is given the memory inside the CPU registers. Difference is that stored in CPU registers, right? Keyword is register. If you want to declare a register integer, so you write register int a comma b, or in this way. Now what is the use of declaring a variable as a register? We know that CPU register is very fast. Now when you need a variable most frequently, then that variable you should declare it in register, because the access time will be reduced. So you declare the variable which is most used in the CPU registers. Now CPU registers are limited. What if CPU registers are not free? Then in such a case the variable is treated as an auto variable. Now a register variable is stored in CPU registers. The uninitialized value is garbage. The scope is within the block, similar to the auto variable. Lifetime inside the block, same as an auto variable. Now there is another type of storage class known as external storage class, also known as global variables, right? They are stored in data memory. Now your program is divided into stack memory, data memory, and a lot of program segments. Now in those divisions, global variables reside in data memory, actually in RAM. Now when you declare an external variable or a global variable, it is always initialized to 0, right? When you don't initialize the value, it gets automatically initialized to 0. The scope is global. It is accessible to all functions, or it is accessible in all parts of the program, and the lifetime is until you end the program. Those live on. You can access till the end of the program. Now the last type of storage class is static storage class. The variables declared are called static variables. These are also stored in RAM or the data memory. Uninitialized value is 0. The scope is local to a block, similar to what we saw in automatic variables, but the lifetime is retained between function calls. Now what are functions, what are function calls, we'll study in some other videos, but the lifetime, you should remember that static variables lifetime is that it is retained within function calls. Now you have a choice. of choosing a storage class. Now when do you choose auto, register, external or static? External or static. Now auto, when it is a default class, it is used in most of the cases. You use register when the variable is accessed most frequently, right, to reduce the access time. External if it is required in the whole program. It is required by all functions of your program. Static when the variable's value is to be retained between function calls. When you call a function, and when you return from that function, when the control returns from a function, the value should be retained. We'll study that. We'll study static and external variables in some other video lectures, but for now remember these things. Okay, that's all we have for in this lecture. Thanks for listening. If you have any queries or any suggestions to give, you are welcome on this email address. Thanks for listening.